Hi everyone, in this video lesson we're going to be looking at prime decomposition. And how do we go about that? Well, pretty much these little inserts will give you some idea, but we'll get to that shortly. Alright, well, every composite number can be expressed as a product of its prime factors. Alright, so in order to do this, the easiest way to do it is to use a factor tree. Alright, so I'm going to use 48 to demonstrate the factor tree. Remember, what are factors? Factors are two numbers that are multiplied together will give me the number 48. What two numbers multiplied together give me 48? Well, I'm just going to go with 4 and 12, because 4 lots of 12 definitely give me 48. But that number and that number there are not yet prime numbers, are they? They are still composite numbers. Therefore, I still need to break them down a little bit further. So what multiplied by what is going to give me 4? Well, 2 multiplied by 2 is going to give me 4. And what multiplied by what is going to give me 12? Well, I'm going to go with 4 multiplied by 3. 4 multiplied by 3 definitely gives me 12. However, I've still got a problem. That now is a prime number, that is a prime number, that is a composite number, and that is a prime number. So I still need to sort this little composite number out here. So what multiplied by what is going to give me 4? Well, it'll be 2 multiplied by 2. So this whole thing over here is what we call a factor tree. And we now have prime number there, a prime number there, a prime number down here, another one there, and another one over there. They're at the end of these little branches. Okay, so imagine this is a tree and these are all branches. These are at the end of the branches, and these are all prime numbers. So I'll just identify the prime numbers. There we go. Those are the 4 prime numbers. They're at the end of the tree. So we could actually write that now as 48 is equal to 2 times 2 times 2 times 2 times 3. And therefore 2 to the power of 4 multiplied by 3. And once again, where do I get my 2 to the power of 4? Well, there's 1 2, there's a second 2, there's a third 2, and there's a fourth 2. That's why we've got 2 to the power of 4, and I only have 1 3. So I just write it as a 3. I don't need to put the 1 above it. It's 3 by itself is perfect. Alright, here's one for you to do. Express 60 in prime factor form. Remember to put your factor trees up and put the video on pause, and when you're ready, come back. Alright, so I've got my 60 written up. Now, what two numbers multiplied together will give me 60? I'm just going to go with 5 multiplied by 12. And I now immediately recognize that that is a prime number, but that one isn't yet. Okay, so I've got to sort out this number over here, which is a composite number. So what two numbers multiplied together are going to give me 12? Well, I'm going to go with 3 and 4. So 3 times 4 definitely gives me 12. That there is once again a prime number, but that is still a composite number. So I need to solve that one. So what times what is going to give me 4? Well, 2 times 2 is definitely going to give me 4. 2 times 2 is absolutely 4. Right, so let's identify prime numbers. There's one over there, there's one over there, there's one over there, and that is my 4th prime number for the number 60. So 60 can now be written as 2 to the power of, I've got 2 2's, so it's 2 to the power of 2, multiplied by, I've got a 3, only one of them, multiplied by 1 5. So the breaking down of 60 into prime numbers is 2 to the power of 2 multiplied by 3 multiplied by 5. And it's also very important that you go in ascending order with the prime numbers. So 2, then 3, then 5, and whatever, if there were other numbers that would follow, would come after it. Now here you're saying, but Mr. Eaton, you've only used 5 by 12. What happens if I want to use 2 by 30? Well, let's go. 2 by 30. Well, is 2 a prime number? Yes it is, so we don't need to do anything more with that. But is 30 a prime number? No, it's not. What two numbers multiplied together give me 30? Well, I'm going to go with 15 multiplied by 2. So 2 lots of 15 definitely give me 30. There's a prime number. That is still composite. So I've got to break that one down again. So what two numbers give me 15? Well, I'll go with a 3 and a 5. 3 5s are 15. So 3 multiplied by 5 is going to give me 15. So where are my prime numbers in this example? Well, there's one there, one there, one there, and one there. So for 60 in this particular case, 60 equals, what is my lowest number? I've got a 2 there, and I've got a 2 there. So I'm just going to go 2 to the power of 2 multiplied by, where is my next highest number? Well, there it is over there, so it's a 3 multiplied by 3 multiplied by, where's my next highest number? Well, there's a 5 there, so I'll put my 5 there. Is this particular prime decomposition the same as that prime decomposition? Absolutely, yes it is. So this way of breaking it down, multiplying it like that, or multiplying it like that, they all end up being exactly the same answers. So whichever way works for you, whichever numbers work for you, go with it. And that is the end of the video lesson on prime decomposition.